Hi there, this is Science to Sticks. I'm Paul. Welcome. This one is about how to read the periodic table. Roll the graphic. Once again, I hope you enjoy the little graphic doing its thing. Okay, so let's get straight into this. What I've done back here is I've included a few more things on the details of my initial little bit of information. Now the periodic table happens to have a list of all the elements that exist from number 1, which is hydrogen, all the way through to 100 and something, which is, I don't even know what the name of it is, but I know that it goes up to about 105, 106, maybe even beyond. But it comes with a couple of things when you're just looking at it in an exam. You've got this weird little set of letters. This is the chemical symbol, or at least the atomic symbol. He in this case stands for helium. H, capital H, is hydrogen, capital C is carbon, and it goes on. So the single letter or the couple of letters that there represent what symbol it is going to be when put in compounds or indeed used on its own. So in the case of helium, it is He, it is the first two letters. Some of the elements are named after their Latin names because they've been in existence with humanity for many, many years. So for example, gold is AU, silver is AG, and of course we don't use GO or SI for silver and gold. So just be aware that those are very, very common in the periodic table. So let's press on. What else is present? Well, we've got the symbol, and then we've got two numbers. You have a small number and a big number. The small number tells you how many protons that are in the atom. This tells you essentially the name of the atom. If you know what the small number is, you can find out on the periodic table what exactly is the name of the element. In this case there are two, and the second one in the periodic table is helium. So even if you did not know this, there was an X there, and we'll discuss this in another video, you would know, well, that's got to be an atom of helium of some description. The next number is the big number. This is the number of protons and neutrons added together in the nucleus. Protons and neutrons. It is called the relative atomic mass. Now, higher tier students in A-level chemistry and GCSE chemistry will need to know a little bit more about why it's called the relative atomic mass, but for Joe Public and the rest of GCSE people, and even just folks just watching and going, oh, I didn't know that, I know that now. Relative atomic mass, the number of protons and neutrons that are in the nucleus. So let's have a look at what a nucleus looks like. Let's have a look at what the rest of this atom looks like. Now, all atoms have three subatomic particles, protons and neutrons, and they are in the nucleus of the atom. And they also have whizzing around the outside, like planets around the star, they also happen to have electrons. Now, because all atoms on the periodic table are considered to be neutral, because protons have a positive charge, neutrons have no charge, and electrons have a negative charge, the number of protons that has, in this case, 2 protons, it will have an overall plus charge in the nucleus, which means it must have an overall 2 minus with the electrons. So let's draw this. Now, as it happens, and this should be obvious, atoms are small. They're really, really tiny. Not only are they really, really small and really, really tiny, what is in this space between the electrons and the nucleus, there is nothing there. There is no air. There is no other atoms. This is an atom. This is the smallest unit of matter that exists. Of course, the bigger the nucleus, the bigger the atom. So things like iron happen to be pretty heavy because they've got a fair number of protons. But let's check this out. Here I've got pluses. These represent the protons. They are positively charged. I've got zeros. They have no charge. They are also in the middle. So this here is the nucleus. Zipping around the outside of the nucleus like planets around the star or around the sun. Again, like, not is, like. We have electrons. The area in which they can be found are called orbitals or shells. And there are rules and laws to govern how many can go in each shell, because there are lots of different ones. So that really wraps up how to read a symbol the proton number, the mass number, and what it is. Till next time, ladies and gentlemen, as always, stay cool. Bye-bye.